So for my project over Boyle's Law, I had 4.1 through 4.6, and this is minor objective 4.1, the relevance of the question. So my question would be practice problem. A gas has a pressure of 120 kPa and a volume of 4.0 liters. If the volume is compressed to 2.0 liters at a constant temperature, what will the new pressure be? So this one relates to the Boyle's Law because it shows how the pressure and volume are inversely related. When the volume is cut in half, the pressure doubles, and it follows Boyle's Law since the temperature stays constant and the gas is compressed. So for minor objective 4.2, benefits of understanding the question. Understanding the question helps show how pressure changes when a gas is compressed or expanded. This is important in real life when you think about breathing, when you think about syringes, and then scuba diving. And then if you really think about it, all of the refineries, how they compress gas to make a product, do all that, they're running billion-dollar companies, maybe even trillions. And so for minor objective 4.3, my process of writing the question. So we already know that the volume is P1 times V1 equals P2 times V2. So to create this, you first choose your starting values for the pressure and volume, then you change one of the variables, like decreasing it, and then while you're keeping the temperature constant, and then you plug them in. So for 4.4, minor objective 4.4, the uniqueness of the question discussed. It's unique because it uses a simple situation compressing a gas, to show you how the formula really works and how to prove Boyle's Law. And so the pressure is normal, and then it increases, and it shows you the temperature change. And so for 5.1, a relevant chart, whenever it's going down, the other one will either go up or it could be the opposite. And then for relevant formulas, we have P1 times V1 equals P2 times V2. It means that the initial pressure times the initial volume equals the final pressure times the final volume, as long as the temperatures are staying constant. So minor objective 5.3, the solving process. So you have step 1, the given values. P1 equals 120 kPa. The V1 is 4.0 liters, and then V2 is 2.0 liters. So you have everything except for P2. So you plug in and solve. You would do 120 kPa divided by V1, and so that's 120 times 4 equals 480, and that's where you divide the 120 kPa times V1, which is P1 times V1, and then that would be 480, and then you go and you subtract 480 by 2.0 liters to get you P2. So P2, 480 divided by 2 equals 240. So you get P2, 240 kPa. So that would be the volume. And so here I have it when the formula, when the temperature is constant, this equation is used to compare different conditions on the same solution. So for 5.4, I have the solution correct. So the solution of 240 kPa is correct because it follows Boyle's Law. When the volume is reduced from 4.0 liters to 2.0 liters, the pressure increases from 120 kPa to 240 kPa. It shows how the relationship between them stays constant and proves Boyle's Law correctly. So for minor objective 6.1, additional valuable information provided. It's used, Boyle's Law is used in many real-world situations involving the air and gases. So, for example, I put bicycle pump. When you compress the air is shot through the tube, through the needle, into the tire. So as you're compressing it, it's going in. And then you expand it, and then it's going back in. And we use that in there, scuba diving, all kinds of things. And then minor objective 6.2, the additional interest. I found it interesting how all of our everyday lifestyle is affected by Boyle's Law. And before this class, I never even thought to think about it like that. But the bicycle pump, I can't tell you how many times I've used a bicycle pump or a pump in general, and I didn't realize. And then compressing it, the refineries, they use compressors, pumps, and it's a company running off of simple physics that make them so much money. Not all of it is simple, but it's cool to think about how all of that ties into Boyle's Law and how that helped to get plenty of people jobs. And so for minor objective 6.3, the overall summary, Boyle's Law explains how the pressure and volume are related in a gas when temperature stays the same. As the volume is decreasing, the pressure increases, and as volume increases, the pressure decreases. And it's important for understanding how gases behave in real life situations. And then minor objective 6.4, the relevant sources. And that's it.